The ocean is one of the most beautiful jewels of nature. It shelters a fauna and flora of an incredible beauty and richness. Since the beginning of the history of mankind, men have been closely linked to the sea and fascinated by this blue immensity. The underwater depths are all the more coveted and fascinating as they still remain a mystery, despite all the technical inventions we are capable of. Man can travel on land, on sea, in the air, and even in the universe. He has walked on the moon, observed and studied many planets thanks to state-of-the-art tools. Man's knowledge of the environment that surrounds him has become more and more extensive over the centuries. However, there is still a big unknown in this equation of human knowledge: the ocean and its immensity. The distance between Earth and the Moon is 384,400 kilometers, or 238,855 miles. The distance between Earth and Mars is between 54 and 70 million kilometers, that is to say, more than 40 million miles. But let's get back to the Big Blue, the immensity of the ocean and the magic of the deep. We know that the deepest abyss is 11,000 meters. That is more than 36,000 miles. It's incredible to think that the ocean can be that deep, isn't it? And yet, this is nothing compared to the distances we are able to travel on land, in the air, and even out in the universe. Nevertheless, we know much more about our solar system, which is so far away, than about the abyss, which is so close to us. Dear Voyager, good morning. Today, I take you through an exceptional journey in the deep sea. Think of liking the video and subscribing to support the channel. Thank you all, and enjoy the video. "71% of our planet is formed by the oceans, and the abysses constitute 3/4 of these marine areas. The majority of these areas are still unexplored by man. Despite our technological progress and knowledge, the ocean is far from having revealed all its mysteries. For many of us, the underwater depths are dark, cold, dangerous, and scary. But do we really know the depths of our oceans? If we still lack knowledge about these oceanic regions, recent studies and exploration give us some answers about the abyss. They offer us essential keys to better understand the marine universe and the world around us. I invite you now to dive with me into the depths of the ocean. You will glimpse the history of the abyss through the centuries, discover its legends, but also its fauna, its flora, its composition, and its role in our ecosystem. Are you ready? Take a breath of air, close your eyes, and dive with me into the blue immensity. To understand why we preserve such an image of the abyss, we must go back a few centuries. Our history has fed our present. Yesterday's thoughts have become today's beliefs. For centuries, man was unable to visit the underwater world. Submersibles and other equipment dedicated to underwater diving are still very recent. This is why scientific studies and popular knowledge were limited for many years to the partial observation of the sea and the examination of animal carcasses found on the coast. Often swollen by water or damaged by time, they did not resemble at all the appearance of the animal when it was alive. These observations led to assumptions that were often exaggerated and erroneous. In the collective imagination, the abyss is therefore limited to a dark, cold, and terribly hostile underwater area. They shelter gigantic and frightening creatures. On this subject, we can evoke the legend of the Kraken, which has been around for many years. In the Middle Ages, far from being perceived as a simple joke, this fable with Scandinavian origins managed to destabilize sailors around the world. Many attacks were attributed to this creature with giant tentacles. Dozens of sailors said they had seen a monstrous, aggressive, and gigantic creature. Fears established, and the testimonies multiply. Carl Linnaeus, naturalist of the 18th century, Eric Pontoppidan, George Show, botanist in the 19th century, and many others all have a common point. The object of their study was the kraken. Kraken means octopus in Old Norse. For several centuries, sailors thought they were dealing with the kraken. It would attack the boat and be responsible for several shipwrecks. As the phenomenon became more and more widespread, various scientific bodies were called upon to understand what was happening at sea. Thinking they were perfectly documented on the subject, the scientists of the time relied on the numerous testimonies of sailors to study the phenomenon. Bodies swollen by water, remains of animals with an enigmatic look, testimonies exaggerated by fear and lack of knowledge. It doesn't take more to give life to a legend. Scientists evoke these facts in numerous accounts and books. Their enlightened word necessarily expresses the truth to the population. At least, that's what people thought at the time. This is how the story went from myth to reality. Oral traditions like this one are numerous. They popularized these false beliefs and this truncated vision of the abyss by the people. The abyss, so near and yet so far, has become a source of anxiety and fear. Many people maintain a very negative image of the deep sea. The depths are often linked to the notion of danger. This idea that we have formed of this part of the oceans is ultimately the result of our lack of knowledge on the subject. Legends and myths passed down from generation to generation. The lack of technical means and scientific knowledge has slowed down our hopes of discovery, but not our thirst for knowledge and our deep love for the ocean. It is even an inexhaustible source of creative inspiration for authors of novels and screenwriters of the seventh art. For decades, these artists have been nourishing the imagination of their production by taking inspiration from the abyss. Most of these underwater regions are still poorly known to us, and the unknown inevitability leaves room for mystery and imagination. All the beauty of creative inspiration comes from this part of the imagination. Many authors choose the abyss as the main setting for their works. Jules Verne, for example, published in 1869 in his series Voyages Extraordinaires, one of the flagship novels of his literary work, 20,000 Leagues Under the Sea, the plot of which takes place in the depths of the sea. Incredible or disturbing creatures, fantastic theories, everything becomes possible. The ocean has always been a universe apart, almost elusive. It has therefore given rise to many legends. First of all, we can mention the city of Atlantis. According to the legend, the city would have been swallowed up by the waters. The anger of Zeus was such that he provoked earthquakes and exceptional floods in order to punish the Atlanteans for their pride. Plato is at the origin of this myth. According to his writings, the city would be in the Strait of Gibraltar. The underwater monsters also feed many legends. This is notably the case of the famous kraken. This giant squid has impressive measurements, up to 15 meters. That's almost 50 feet. It is probably this animal that was the muse of some writers like Jules Verne and Victor Hugo. According to these stories, the sea is full of all kinds of sea monsters that decimate entire crews. But one of the most popular creatures of the oceans is undoubtedly the mermaid. Sometimes benevolent, gentle, and allies of sailors, sometimes bewitching, Machiavellian, and wicked, mermaids fascinate. In Greek mythology, mermaids seduce sailors with their voice and song. They drive sailors to madness until they themselves cause the sinking of their ship. Many sailors are convinced that they have seen these women during their expedition at sea, and for the little anecdote, Christopher Columbus is one of them. Do you know the famous English proverb, "A ship that has not tasted wine will taste blood"? To bring luck to the sailors, but especially to ensure that the ship is under the protection of the gods, the ship is christened with a bottle of champagne. This tradition comes in part from ancient Greece. At the time, a person was sacrificed for the occasion, and his blood was spilled on the bow of the ship. A bit cruel, we must admit. The following generations have preserved their tradition, while modifying some parameters, fortunately. There is no longer a human sacrifice, but a simple bottle of wine in the story. If blood was replaced by wine, it is because it symbolizes the blood of Christ and divine protection. Nowadays, champagne is more preferred. It symbolizes celebration, but also happiness and luck. Champagne is associated with the significant events of life. The tradition is still alive today among sailors. Did you know that the White Star Line was one of the companies that did not christen their ships? When the Titanic sank in 1912, the population saw this as a sign, a bad omen. Since then, each new ship is baptized before leaving for the first time to meet the ocean. The ocean is so vast that to understand and analyze it as a whole, scientists use a specific vocabulary. Before taking you on a journey into the depths, a few words about these famous terms. The ocean floor, also called the seabed, includes everything that makes up the bottom of the globe submerged by the sea. These bottoms are cut into several parts according to their depth. The first layer is called the continental shelf. It gradually descends to the bottom of the ocean and extends to about 200 meters or 650 feet deep. It is an extension of the continent that is submerged by the waves. Then comes the continental slope and the continental glacis. This time, the descent is in spades. We decrease almost from 200 to 4,000 meters deep. That is to say, more than 13,000 feet, in very abrupt ways. The slope and the glacis serve as a link between the continental shelf, which is at the top of the seafloor, and the abyssal plain, which is almost at the bottom. The abyssal plain, as its name suggests, is extremely flat. It lies between 4,000 and 6,000 meters deep, or almost 20,000 feet. It is what we might call the floor of the ocean. On this floor, there are many seamounts and volcanoes. Their tops can sometimes reach the surface of the sea. Conversely, the abyssal plain also has trenches. These pits are gigantic holes that can reach more than 10,000 meters deep, that is to say, almost 33,000 feet. Many phenomena take place in the depths, such as erosion, i.e. the process of degradation and transformation of soils, rocks, and banks, or sedimentation, which allows particles to no longer remain in suspension, but to settle to the bottom and become sediment. The seabed also has a geoclimatic role, i.e. it has an impact on the climate. The seabed must be seen as carbon sinks. These wells are like large reservoirs. They can store CO2 in very large quantities and over the long term. We never go to the abyss, except for scientists, and yet this place is essential to our life on Earth. We are totally dependent on it. Seawater is 96% water, and we would be tempted to say 4% salt. But many other substances, of course, to a lesser extent, are also present. Although they are very small compared to the other components, they still play an essential role. Chlorine, sodium, magnesium, sulfate, calcium, potassium, bicarbonate, bromine, boric acid, carbonate, and fluorine. In all, nearly 79 other elements make up the sea. A subtle mixture between all these molecules that allows a physicochemical reaction. Sodium and chlorine give rise to sodium chloride, the scientific name for sea salt. The continental shelf is the part richest in sediments, and the abyssal plain the poorest. Sedimentation is long and weak in the ocean, only 1 centimeter every 1,000 years. Would you have imagined that it would take so long? It takes Mother Nature a long, long time to do her job, which is why the ocean is so beautiful and fragile at the same time. To get back to our sheep, or rather our particles, most of the sediment layer is formed at the foot of the continental slope, where the slope is the steepest. It is a bit like a slide. All the sediment rolls and slides down this slope to reach the bottom. The sediments come from the erosion of the continents, with the transport by wind, rain, human activity, etc., but also from the organic remains of marine animals and plants. It is thanks to the transport of sediments from the coast, due in particular to the erosion of the continents, that the sediment falls to the bottom of the sea and accumulate at the floor of the continental slope to form the continental glacis. This part of the bottom is just before the abyssal plain and is slightly bulging because it contains all the settlements that have slid. Between 1872 and 1876, the first explorations aboard the HMS Challenger allowed depth surveys to be made. To determine the depth and to study these bottoms, the scientists used the plumb line technique. Imagine how laborious and rudimentary this work was. It is an interesting first approach, but it is still limited. The only thing we know about the sea floor is its approximate depth. We have no knowledge of the fauna, flora, relief, or geological composition of this element of our environment. During the Second World War, men managed to build more and more advanced and precise devices. In particular, they used the acoustic system and magnetism to determine lengths and precise points. In 1950, an American geographer and cartographer, Mary Tarp, succeeded in making the first map of the ocean floor. This was a major advance in the history of our knowledge of the underwater depths. In 1978, bathymetry, the science of measuring the depths and landscape of the ocean, took a new turn thanks to sonar. Multi-beam sonar then revealed previously unsuspected landforms, mountains, plains, volcanoes. Finally, in 2014, a new gravimetric map of the ocean floor will be developed, this time using satellite data. This combination of data from 2 satellites allows to highlight the horizontal resolution of the ocean. More precise, this technique highlights still unknown faults and allows to specify the extent of some landscapes, especially the small abyssal hills. As you can see, our precise approaches to the ocean are still very recent. If we have more knowledge on the subject, the Big Blue still promises us some surprises. But for the moment, it is time for you to go on a trip. You have the knowledge and the equipment to become the perfect deep sea explorer. We're going to start a descent into the abysses. The deep blue sea is holding out its arms to you. You will discover an incredible universe. Let's dive together, little by little, step by step, into the depths of the ocean. Minute after minute, meter after meter, we will go down lower and lower, deeper and deeper, to discover all the beauty and magic of this extraordinary element, the ocean. This approach to the ocean floor is called the verticality of the ocean. Let's open together the doors of an extraordinary world. It is a world of 1,000 wonders that awaits you. This zone, also called the Epipelagic zone, photic zone, or simply sunny zone. Before diving much further, much deeper into the ocean, it is necessary to know some essential points of this first layer of the ocean. The sunny zone, as its name indicates, is the zone where the sun's rays can spread their light. This is the area where, as a child, you would swim at the beach. It is also an area where some of you have had the chance to go scuba diving, to discover this enchanting world. Fish of all colors, all shapes, extraordinary marine animals, corals, and plants that dance with the waves. This area is about 200 meters or 650 feet deep. The term photic is used in relation to the sun's rays that penetrate this layer of the ocean. In this marine area, photosynthesis of plants is possible. The organisms can, through bioenergetic process, synthesize organic matter. For this, it needs light, water, and carbon dioxide. All these parameters are gathered in the photic zone. This zone is shallow and begins near the coast in the shoreline. It lies on what is called the continental shelf. The continental shelf is the part of the continent covered by a thickness of water, generally quite small, 100 meters maximum. This zone, which amazes children and adults alike by its beauty, is a key element to understand the rest of the ocean, and therefore to be able to go deeper into the abyss. The Epipelagic zone, which means surface of the sea in Greek, is the liquid and sunny surface of the ocean, where temperatures vary the most. They can reach extremes of -2 degrees Celsius or 28 degrees Fahrenheit, especially in the poles. I can already see you frowning with incomprehension. Water freezes at 0 degrees Celsius, or at 32 degrees Fahrenheit and below. How can it be that this surface is not made of ice and remains in a liquid state? It is not seawater, but fresh water that solidifies at this temperature. Salt water manages to remain in a liquid state at lower temperatures. Conversely, the Red Sea can record temperatures of up to 32 degrees Celsius or 90 degrees Fahrenheit. The other zones have some temperature differences, but never as large as the Epipelagic zone. Another essential element to understand before continuing the journey: the Epipelagic zone is at the top of the marine food pyramid. All the deeper layers depend on this ecosystem located at the surface of the sea. For example, photosynthesis, on which many animals and plants depend, is carried out by microalgae called phytoplankton. These organisms are the key to marine life and develop in the sunny areas of the sea. "90% of marine life is located, according to our current knowledge, in the photic zone. We are familiar with this part of the ocean, which is accessible from our coasts and which is not subject to oceanic pressure. Yes, we had not yet mentioned this phenomenon. I think this is a good time to take stock of it. As we have seen previously on the history of the discoveries of the abysses, the pressure of the water was a brake to venture into the depths. In the 18th and 19th centuries, we had neither the knowledge nor the technical means to develop a device capable of withstanding this pressure. The greater the depth, the greater the pressure. To understand this phenomenon, we must visualize the water above and below a diver. At the surface, the diver has little or no water above him, therefore it weighs nothing. However, the deeper the diver goes into the water, the more water there is above him or her. If we consider an object, such as a submarine for example, we must also know that pressure acts equally in all directions, i.e., the pressure due to the weight of the water is felt on the top, bottom, and sides of an object. Why is this? Because the water above exerts pressure, but so does the water below. That's why it took so long to develop a device that could withstand the pressure of water. You need a very strong, robust, and solid material to build a submersible. Now let's talk about measurement. To estimate the pressure, we measure it in ATM. There are other systems of measurement, but this one is the most commonly used by scientists in the maritime field. ATM means atmosphere. 1 atmosphere is the average atmospheric pressure at sea level. Then every 10 meters, i.e. every 33 feet, the pressure increases by 1 atmosphere, i.e. 1 ATM for 10 meters. To give you a concrete example, when you make a dive to 50 meters or 165 feet, so 5 times 10 meters or 5 times 33 feet, you experience a pressure of 6 atm. Oh, I think I see your eyebrows furrowing again. If you count 1 atm per 10 meters, 50 meters should equal 5 atm. Don't worry, you're still good at math, your brain isn't playing tricks on you. But you forget one little detail. The air pressure at the surface of the ocean is also 1 atm. So at 50 meters, there are 5 atm for water and 1 atm for air, for a total of 6 atm. Pressure is also expressed in bar. 1 atm is the same value as 1 bar of pressure. I hope you've enjoyed our nice cruise in the photic zone, but now it's time for you to move on to the next step. For that, we will have to move away from the coast. This area is located at the top of the continental slope, just below the continental shelf. You're now going to go down a little further into the depths, between 200 and 1,000 meters, or between 655 and 3,280 feet. We're going to make a short stop in the Mesopelagic zone, called the aphotic zone. Remember a few moments ago I told you about the photic zone, which got its name from the sunshine and photosynthesis. As you can imagine, the aphotic zone no longer receives the sun's rays, and therefore its heat and light. It is darker and colder. Can you feel it? In this zone, the pressure is also higher. Depending on where you are, the pressure is between 20 and 100 atm. How are you holding up? Then let's go exploring. This part of the ocean is unknown to the general public, but not to scientists. We have some data on the subject, and several studies and maritime expeditions have been conducted to better understand this particular environment. Up to 500 meters or 1,640 feet, the waters of the Epipelagic zone and the Mesopelagic zone can mix. This is why temperature differences can still be felt. Between 500 and 800 meters, i.e. between 1,640 and 2,625 feet, the temperature starts to drop. Depending on the area, it can vary between 6 degrees Celsius, 43 degrees Fahrenheit, and 20 degrees Celsius, 68 degrees Fahrenheit. Then, temperatures continue to drop, sometimes drastically, to about 2 degrees Celsius, or 36 degrees Fahrenheit. This is called the thermocline, the zone of rapid thermal transition between the warm, oxygenated surface waters and the colder, saltier deep zones. Beyond this imaginary line, the thermocline, the temperature no longer varies. It stagnates and balances over the entire surface of our planet. There are some exceptions, very deep areas that are still very hot, but we'll see that later on in our journey. Let's go back to the Mesopelagic zone for a moment. As you can imagine, in these colder and deeper waters, survival is more difficult. But this does not mean that life does not exist. On the contrary. Many species of fish, but also invertebrates, live in this particular area. We find in particular the haddock fish, the wolf eel, the cat shark, the bottlenose dolphin. You can see this small seaweed in the distance. It is the kelp. Look how extraordinary they are. Isn't it incredible that they managed to live in such difficult conditions? The level of light is low. Oxygen and temperatures are decreasing. Salinity and pressure are increasing. So, how do they live? To find out, look around you. Observe these exceptional animals. You will see that only 2 options are available to them. The first survival technique is to take advantage of the plankton particles that fall to the bottom of the sea. These are the leftovers, the crumbs left by other species, but without them, the life of many marine animals would be impossible, and these animals are part of the marine ecosystem and maintain its vital balance. As I explained earlier, microalgae are an essential part of underwater life. This is why it is at the top of the food pyramid in the ocean. The second option is to be an outstanding predator with exceptional abilities. This is the case for a majority of marine animals that make their home in this area of the ocean. The firefly squid attracts its prey with the light produced by its tentacles. It uses bioluminescence, that is to say that it is able to produce its own light only thanks to its body. The angel shark, a majestic sea slug that uses its wings to propel itself through the water, is a small mollusk that does not have a shell. It feeds by grabbing its prey, gastropods, with its tentacles and spinning it around. The emperor penguin can swim up to 530 meters, that's 1,740 feet deep, to feed. It has the ability to travel almost 2 kilometers or 1 mile in the water to feed and come back to the surface. Other well-known animals, such as some dolphins, whales, seals, and sea lions, also hunt in these deeper waters. We will continue to descend a little more. We're now at a depth of 700 meters, or 2,300 feet. You'll discover during the trip more and more surprising animals by their morphology, their size, their hunting method, or their age. Here, the Nautilus lives happily. It is a relic of ancient times. Its existence goes back to more than 500 million years. The small filaments that you can see sticking out of its shell are tentacles. It has about 90 of them. A little further, this giant crab that you can discern on the ground thanks to its color is the Japanese spider crab. Its leg span is 3.8 meters, almost 13 feet. This is a record to date. No other crab species exceeds this size. Another impressive phenomenon is the sunfish. It can weigh up to 2.3 tons. It is one of the heaviest bony fish in the world. How can a fish that weighs between 1 and 2 tons for the most of them move so easily in the water? A little further down, here is the giant Pacific octopus. It likes rocky habitats and reefs. With its 4 pairs of arms about 3 meters long, almost 10 feet long, it is a formidable deep-sea hunter and an expert in camouflage. Look at this Maris orthicana coming in. The enchantment and the fantasy invading the ocean. It is not an animal, but a colony of zoids. This is an elemental animal that composes living in a colony with its fellow creatures. The colony comes from a single fertilized egg. Then, the first zoid buds to form the other members of the colony. They are all genetically identical. The first zoid, called a protozoid, thins and elongates to form the central stem of the colony. It feeds on small crustaceans. To feed, its tentacles can extend up to 50 centimeters, almost 20 inches. It moves forward intermittently, then takes out its fishing lines to trap its prey. Isn't it fascinating that such a basic animal can survive so easily in hostile conditions? The blobfish is another example of this wonderful adaptation of fauna and flora to their environment. If this deep-sea fish is known for its ugly and strangely human appearance, it is nonetheless fascinating. The pressure is 60 to 150 times higher than what we can feel at the surface. The constitution of this abyssal fish is therefore particular. It has a gelatinous flesh with low density and a very light cartilage. It has very few muscles, but this does not handicap it. It uses very little energy to move. It floats a few centimeters from the bottom of the sea. Although vegetation is almost impossible at such a depth, since only 1% of the sunlight reaches the Mesopelagic zone, the fauna is nevertheless rich and varied. In some areas, it benefits from corals, which provide it with an ideal living place. The most famous is undoubtedly the Great Barrier Reef, located on the Australian coast. It extends over more than 2,500 kilometers, that's 1,550 miles, and according to astronauts, it is even visible from space. The corals are home to nearly 1,600 species of fish and shellfish. They serve as shelter for fragile species, but also as food for others. Their lives are directly linked to the corals. Without them, their life is threatened. We're now going to pass under 1,000 meters, or 3,280 feet of depth, to begin the descent of the Bathyal zone. It extends from 1,000 to 4,000 meters, i.e. between 3,280 and 13,000 feet. It is located between the continental slope and the continental glacis. The latter forms the slope that connects the continental shelf and the seafloor. It channels the flow of sediments, of which it is mainly composed. Large pieces can fall after an earthquake, but there are also finer sediments due to natural erosion, waves, runoff, etc. To give you a small idea of what the continental glacis looks like, you could imagine a landslide, but underwater. Here, it is only 4 degrees Celsius, or 40 degrees Fahrenheit, and many species are blind. But what good is sight to them anyway? No light, no matter how small, shines through here. Can you feel how oppressive the darkness is? For us humans, it is an unbearable, repulsive, and hostile environment. We're used to using our visual sense. It is one of our main reference points to apprehend our environment. But forget your human sensations to better understand the animals of the deep sea. Put aside your prejudices for just a few minutes. You were born here and perfectly adapted to your environment. Like 80% of abyssal species, you are able to emit light thanks to a chemical reaction. Your body is covered with a very black skin, which allows you to absorb 99.5% of the light. You are thus completely invisible for your prey. Your asset to survive in this hostile environment is your bioluminescence. When you emit light, you attract your prey and enjoy your breakfast. Here, no plant can find the elements necessary for its development. It does not exist in these shallows. No species of fish feeds on algae or plants, except for crustaceans that feed on organic debris. The other marine animals are all carnivores. These carnivores play an important role in the marine ecosystem. They regulate the development of certain species and clean the bottom. Without this, many corpses would clump together. The hagfish, the flying shark, and the sleeper shark that you can see hunt, but also feed on the carcasses that fall from areas higher in the ocean. Another physical survival adaptation is that of eels. Their long, slender bodies allow them to withstand the high pressure. The Mesopelagic zone is also the kingdom of the vampire squid. Do not fear its name. Our imagination plays tricks on us when we use this kind of term. Our whole system is put on alert by fear, but this animal is neither a squid nor a vampire. So why did you give it this name? Well, simply because of its morphology. Its cape-like structure resembles the wings of a bat. These mollusks are close cousins of octopuses. To feed, they descend on their prey and wrap them like a cape or a net. Before leaving this place, look at this sperm whale. It is true that they are regularly seen in the shallower parts of the ocean, but their head is made up mostly of tissue, and therefore allows them to withstand the pressure. They regularly venture into the depths to hunt more or less imposing prey, like the giant squid. Are you ready to continue the descent? Come on, follow me. Many discoveries still await us a few meters below us. You are in the penultimate layer of the ocean, and probably the most impressive of all. Located between 4,000 and 6,000 meters deep, that is between 13,000 and 20,000 feet deep, it makes up nearly 80% of the ocean floor and more than 60% of the surface of our Earth. All the blue vastness visible from the coast is only a tiny drop of water compared to what the abyssal zone represents. And here, now, you have the chance to discover this incredible place. It lies on the abyssal plains, also called ocean floor. This landscape covers almost 60% of the Earth. It is called a plain because it is very flat, probably the flattest on Earth. The seafloor begins with a slope that extends from the continental shelf to the glacis, then flattens out. In some places, a deep trench may appear. These are the oceanic trenches. The oceanic crust of the abyssal plain is very thin, so it is more malleable, and it is here that the tectonic plates meet. They then give birth to mountains, volcanoes, or chimneys. We will discover their secret a little later. For the moment, let's enjoy our trip a little bit more, in the immensity of the ocean. When you go so deep into the water, you probably imagine that the fauna and flora are getting rarer, right? Well, think again. Our trip promises 1001 surprises. The biodiversity of the abyssal zone is extremely rich. To tell you the truth, it would even be as rich as the rainforest, according to scientists. Undergoing a pressure of 600 bars to more than 1,000, the organisms living in this part of the ocean have a structure and an appearance quite different from what we are used to meeting. To give you an idea of what this value represents, you can imagine the weight of a car on a sheet of paper. A few inches away from you, if you take the time to look at the ground, you'll probably see a giant tube worm. This species of worm is also called a riftia. It lives near the black smokers. We will have the opportunity to discover this particular phenomenon a little bit later in our journey. For the moment, fix your attention on this species of worm. It can measure up to 2 meters, or more than 6 feet. This marine organism is extraordinary. It has no mouth, no intestine, not even an anus, and yet it manages to feed itself. It is equipped with red retractable gills, protected by a whitish tube. It lives in symbiosis. Living in symbiosis means that 2 species are dependent on each other. Their survival is directly linked to the symbiotic species. This is the case of the clownfish and the sea anemone. The clownfish offers its protection, it is very venomous, and the sea anemone, in return, offers its crumbs of its meal because it cannot move. The riftia manages to capture inorganic compounds and passes them on to the bacteria. The bacteria, in turn, use these compounds to grow and transform them into organic matter, which the worm can feed on. It's crazy how well nature works, isn't it? This harmony between beings is so incredible and magnificent to observe. This time, we enter the very last layer of the ocean, the deepest and without a doubt, the most mysterious. Few humans have ventured this far. You have a huge chance. James Cameron reached this depth in the Marianas Trench at 10,898 meters deep in 2012. That's over 35,755 feet deep. Passionate about the deep sea, he was the first to dive solo into the Marianas Trench in the heart of the Pacific Ocean. After a descent of almost 2 hours and 30 minutes, he came back with unbelievable images. It is very difficult to go into these shallows, to study and map them. This requires the use of state-of-the-art satellites, submersibles, and wire-guided underwater drones. Despite our technological progress in this field, it is still very complex to implement. This is why only 15% of the ocean floor is mapped. The landscape, by color codes, highlight the continental shelves, the oceanic ridges, we'll talk about them soon, the depth, and the oceanic trenches. The Hadal zone takes its name from the Greek Hades. This is the name given to the god who ruled the underworld. This zone is located beyond 6,000 meters of depth. That is to say, beyond 20,000 feet of depth. Unlike the other layers of the ocean, this is not a continuous zone. It is found at certain specific points of the globe. There are 13 oceanic depressions and 33 trenches. As I speak, we know 5 of these trenches: the Tonga, Kuril, Philippine, Kermadec, and Mariana Trenches. The Challenger Deep, the deepest point, is located in the Mariana Trench at exactly 10,924 meters, or 35,840 feet. Mount Everest, which is 8,849 meters, or 29,000 feet high, would be drowned by the waves if it rested at the bottom of this trench. At this depth, the pressure is 1100 atm. It is as if 50 airplanes were weighing on you. The animals that live in these regions are very different from what we can imagine. If their physique is not very advantageous, they have the merit of having been able to adapt to extremely difficult conditions. Their survival depends for many of them on chemosynthesis. In these seabeds, hydrothermal springs, a hot water source due to cracks near the magma, allow bacteria to proliferate. These bacteria transform chemical compounds into sugars that other marine species can feed on. Millions of animals depend entirely on the work of these bacteria. They are the only ones able to produce organic matter. Our knowledge is still very limited on the subject, but we already count more than 600 species living near these sources. The further away from these springs, the more deserted the regions are. The oceanic geysers are the only nutritive sources for many animals. The order is perfectly established around the hydrothermal vents. At the closest point to the vents, the temperature is between 40 and 100 degrees Celsius, or 104 degrees Fahrenheit. As you can imagine, not all species can survive such heat. Some worms are perfectly equipped for it. This is the case of the Pompeii worm. Man named it after the ashes that fall in it all the time. This worm is quite different from the tube worm that we met in the Abyssal zone. This one has a digestive system, a mouth, an anus, and even a nervous system and a brain. A little further on, where the water oscillates between 10 and 35 degrees Celsius, or between 50 and 95 degrees Fahrenheit, we again find worms that live in colonies like the tube worm. Around this area, many marine animals use symbiosis to survive. Bacteria use the sulfides in the water to produce energy and sugar. They create microorganisms that allow other species of mollusks, crabs, mussels, or shrimps to survive. We also meet other fish, such as the hydrothermal lycode, which feeds on these marine species. It is one of the few fishes to adapt to such living conditions. Its body is white and without scales. It always swims close to the bottom, slowly. Other species have managed to find techniques to feed themselves, but also to save a maximum of energy. Life at this depth requires an extreme adaptation. Some shrimps, for example, are blind and do not use their digestive tract. They fix all their energy at the level of the head in order not to draw too much from their vital resources. They consume the bacteria of their own organism. The Yeti crab, on the other hand, uses the silk of its claws to collect the bacteria it feeds on. The symbiont is therefore outside its host. Before going back to the surface, I suggest for you to discover the landscape of the ocean. You could realize the richness of the fauna and the flora, the technique of survival, or the physical adaptation of some of them. But we have yet to unravel the mystery of its geography. The continental plain is flat and contains the majority of the layers of the ocean, except the last one, but it is also crisscrossed by rocky mountains. Look around you. This is a real mountain range, buried under the sea. These oceanic mountain ranges are called oceanic ridges. They form when tectonic plates slide under or over each other. This phenomenon of sliding plates also gives rise to marine volcanoes. Sometimes these are so big that they break through the surface of the ocean and form an island. This is the case of the Hawaiian Islands in the Pacific Ocean. The oceanic ridges extend for nearly 60,000 kilometers, or more than 37,000 miles. This is the longest mountain range on Earth. There are also many more undersea volcanoes than are on land. There are tens of thousands of volcanoes under the waves. The base of the ridges can extend 1,500 kilometers, or 930 miles, and their peaks can reach 2,000 or 3,000 meters, or 2 miles below sea level. The structure of the mountain ranges is very particular. It is not continuous as we might imagine. Every 10 to 100 kilometers, that is every 60 miles, there's a fault, called a transparent fault. It is a bit like slicing the mountain at a specific point. What is interesting in the study of these faults is that it reveals a section of the Earth's crust. We can therefore learn more about the composition of the Earth, but also about the history of our planet. The tops of mountain ridges are not linear either. They're notched. They have faults. We call this the rift. It can reach sometimes 1,800 meters deep, that is to say almost 6,000 feet. Now we're going to discover an essential element of the underwater life. The ecosystem of hundreds of species depends directly on this phenomenon. This is the key answer we've been looking for years. How is life possible in the abyss? Hydrothermal vents are like geysers. They are also formed by the movement of tectonic plates. This time, it is not their impact, but their distance that gives birth to new landscapes. When these plates move apart, they form cracks. The magma, i.e. the molten rock from the depths, is then exposed to water, and hot gases escape from the cracks. This is called hydrothermal vents, or smokers. Depending on their characteristics, we can observe black smokers or white smokers. Black smokers are located closer to the surface of the magma. They produce black clouds filled with boiling seawater and dissolved minerals containing sulfur. White smokers are further away from the magma and therefore less hot. Their white color is mainly due to their composition. They contain dissolved minerals such as calcium and silicone. We discovered their presence only in 1977 in the Galapagos Islands. It is thus rather recent. These chimneys allow heat contained in the center of the Earth to evacuate. They are only found on oceanic ridges. It is at this precise location that the magma rises and forms magma chambers. When the magma chamber cools, the magma reacts. It then causes faults in the oceanic crust. The seawater, which is very cold since we're in a zone where the water is about 2 degrees Celsius, meets hot magma, which rises to nearly 1,200 degrees Celsius, or 2,200 degrees Fahrenheit. The contrast between these two extreme temperatures causes an enormous pressure. The hot water then rises towards the ocean floor by washing the rocks on its way. This is how the fluid that comes out of the chimney, which is very acidic, is composed of minerals and gases, but it is totally devoid of oxygen. However, it contains metallic ions, phosphate, magnesium, nitrate, and sulfate. This particular composition allows the ocean to be supplied with iron. When the iron rises to the surface, it favors the development of phytoplankton. You see, the depths of the ocean depend on the surface, but the surface, the photic zone, also depends on the ocean floor. All marine life is a story of symbiosis and harmony. We have long thought that life, even macroscopic life, depends on light. In other words, without light, no life is possible. We therefore thought that the underwater depths were totally deserted by fauna and flora. After various studies and analyses of the environment, but also and especially thanks to the discoveries related to hydrothermal vents, our views have changed. The primary organisms near these hot springs use chemosynthesis. They transform the chemical energy of salts to produce organic elements. This is ultimately the same function of photosynthesis in plants. These organisms form the first link in the food chain in the deep sea. Many species also live in symbiosis. We have seen this for the clownfish and the anemone, or for the bacteria and the tube worm. But they are far from being the only marine beings to use this survival technique. Some symbiotic species, such as the shrimp and the bacteria, are totally dependent on each other. The bacteria live inside the shrimp to grow, and the shrimp feed on the bacteria to store energy. The Mariana Trench is, to the best of our knowledge, the deepest part of the Earth's crust. It is located in the Pacific, precisely where the Pacific tectonic plate passes under the Philippine plate. It was discovered in 1875 during an oceanic expedition aboard the HMS Challenger of the Royal Navy. If today we have precise and easy-to-use measuring instruments, at that time it was not quite the same song. Yes, we had to measure with a rope. But despite our current technical means, measurements are still difficult. The pit has been measured many times, and the results vary between 10,900 meters, that's 35,760 feet, and 11,034 meters, that's 36,200 feet. In January 1960, Jacques Piccard and Don Walsh boarded the Trieste to begin a long descent into the abyss. They managed to reach a depth of 10,916 meters, or 35,815 feet. Before their expedition, we didn't really know what to expect. However, we were sure of one thing: life didn't exist. It was impossible without light, and in such conditions that fauna and flora could develop. However, they observe a shrimp and a flatfish. Imagine their surprise. It is with the passing of discoveries that we then understood the major role of hydrothermal vents and chemosynthesis. Others have since tried the adventure, but they are few. In 2012, it was the director James Cameron who descended into the fault to 10,898 meters, or 35,755 feet. Recently, in 2019, Victor Vescovo also had the chance to see with his own eyes this landscape, a world away from what we know. We often hear about the green lung of the earth, the forest, but we often forget how important the ocean is to our survival on Earth. All marine ecosystems, including the abyss, absorb a colossal amount of greenhouse gases. In fact, methane is their main source of energy. It allows the carbon to be trapped so that it does not rise to the surface. Without it, all the carbon released would lead to serious consequences, including an unstable climate. If the abyss is one of the last unexplored areas, it is not protected from human activities. They are affected by global warming, but also by waste. James Cameron had the bad surprise to see that at such a depth, 10,971 meters, almost 36,000 feet, plastic was present. The fauna and flora of the oceans are extraordinary. The biodiversity is exceptional. Far from being a world apart, it is closely linked to the surface. It is in perpetual interaction with the surface ecosystems. What is absolutely magnificent and extraordinary is that both are so interdependent. The ocean is the perfect illustration of the life system on our planet. All species are dependent on each other and form a whole. Man needs the trees, the ocean, the bees. Here we are. Our journey ends. Now we have to go back to the surface of the ocean to find dry land. If the heart of man belongs to the sea, his body can only survive on land and not in the ocean. We're going to go up gently towards the photic zone, little by little. As the meters go by, the fauna changes, the flora comes back to life, the light becomes more intense. Then you can finally get your head out of the water and take a breath of oxygen. The fresh air on your skin is so pleasant. Your nostrils and lungs are happy to breathe surface air again. Your eyes need a little time to acclimate to the sunlight again. You missed it a bit, didn't you? You have discovered extraordinary species and dived more than 10,000 meters into the depths of the ocean. Did you imagine that such richness was possible in such a hostile environment? Did you think that at a depth of hundreds of meters, corals, thousands of fish, crustaceans, mollusks, and other marine animals had managed to adapt? Today, some deep hydrothermal springs, such as black smokers, are associated with one of the main hypotheses about the origin of life on Earth. Nevertheless, the abyss remains very poorly known. At present, more than 95% of the abyss remains unexplored. The deep sea is mapped with much less precision than the moon, and more people have been to space than to the deepest part of the ocean. Despite the hostility and the many mysteries that surround the deep sea, studies have nevertheless revealed the richness of these extraordinary worlds. They are considered the most important ecosystems for the carbon, nitrogen, and phosphorus cycle, for the production of biomass, molecules of therapeutic interest, petroleum, hydrocarbons, and minerals. These properties have been rapidly studied in order to take advantage of them. The use of black smoker bacteria could solve hydrocarbon pollution problems in coastal areas. The study of sedimentation processes on a large scale could be exploited. The stakes of protecting the abyss are no longer to be demonstrated today insofar as these marine ecosystems participate fully in the regulation of the planet's climate. Whether it is the nutrient marine currents of the depths or the regeneration of nutrients, the underwater life is made of symbiosis and harmony. It is an invaluable jewel of nature. Our journey ends, but the beautiful images we shared will remain an extraordinary memory. The ocean in its immensity is without a doubt one of the most beautiful wonders of nature.